My engineering disaster case study is on the TWA Flight 800. It was a Boeing 747 that exploded and crashed into the Atlantic Ocean on July 17, 1996 at about 8:31 p.m. It was departing from New York and on its way to Paris. The original purpose of the plane was to carry lots of people over large distances in a short amount of time, just like any other planes in the Trans World Airlines, which are the owners of the flight that crashed. The flight was a Boeing 747, as you know. It is an American wide-body commercial jet airliner and cargo aircraft, often referred to by its original nickname, the Jumbo Jet. The original version of the 747 was envisioned to have 150% greater capacity than the Boeing 707, which was one of the common large commercial aircrafts of the 1960s. A cargo aircraft is a fixed-wing aircraft. A jet airliner is an airliner powered by jet engines. Airliners usually have 2 to 4 jet engines. 3-engine designs were popular in the 1970s but are less common today. On Wednesday, July 17, 1996, at about 8:31 p.m., the TWA Flight 800 was taking off from the JFK Airport in New York and was heading to Paris. 12 minutes after takeoff, the airplane exploded and crashed into the Atlantic Ocean. All 230 passengers on board died. This was one of the most deadly and mysterious commercial air crashes in aviation history. Up and down the coast of Long Island and from vantage points as far as 40 miles away in Connecticut, beachgoers, boaters, construction workers, diners, and other made similar sightings, and from more than 22,000 miles overhead, a military satellite had detected heat from something in its vicinity. Recorded eyewitnesses said that they saw a great light in the sky and saw explosions. From some other eyewitnesses, it was said that the nose of the plane had broken apart from the rest of the aircraft and the nose plummeted to the ocean. As for the rest of the aircraft, it was still soaring up into the sky, then started to stall, and it fell back down into the ocean, killing all passengers aboard. This disaster left many families without their loved ones, and they didn't even know that it was coming. They didn't even have any last words to say to their loved ones. Boats were sent out, and again, 100 divers returned to the underwater hell trying to find people, but the impact and time the plane was underwater was enough to kill everyone. As more and more divers were sent down to see how the plane crashed, they discovered more and more bodies. They were able to salvage some parts of the plane to partially reconstruct it. By using advanced computer simulations, we were able to figure out what went wrong with the plane. First off, the air conditioners in the plane were cooling the people but also heating the center wing tank. It was filled with almost 50 cubic meters of highly explosive fuel-air mix. We found out that there was damaged wiring that allowed high voltage current to jump into wiring outside the center wing tank. And then it ran down into the tank, when the current reached a section of bare wire, it jumped into another metal surface, forming a short circuit, which created a spark that ignited the deadly mix of fuel and air. It caused the tank to explode and caused the plane to explode too. Also, the high speeds of the plane caused the damage to spread to the whole entire plane. While there were many conspiracies about what caused the flight to crash, going from terrorist attacks to fuel tank explosions, only one was right, and that was the fuel tank explosion. As a result of the fuel tank explosion, new requirements were designed to prevent fuel tank explosions in the near future. The National Transportation Safety Board learned a lot about fuel tank explosions from the investigation of the TWA Flight 800. They recommended 15 changes to airplane design, inspection, and operation. Some included reducing the probability of an explosion from fuel/air mixture, inspecting testing and replacing certain wiring, tubing, and components inside the Boeing 747 center wing fuel tank, creating design standards such as fault-tolerant fuel tank ignition prevention and flammability reduction, developing maintenance and inspection instructions for fuel tank systems, updating the design to prevent high energy from being introduced into the fuel tank through wiring, and lastly, improving the safety of airplane electrical wiring systems, particularly for aging aircrafts, and through new technology, design, installation, and maintenance. The memory of those who have fallen will never be forgotten.